Okay, so welcome everyone. Thank you for coming. Today we're going to be going over the Python libraries for data science and specifically for machine learning. My name is Lourdes Lopez. My background for the past 10 years has been data analysis and development, but last year I was interested in data science and attended a meetup in Fresno called Fresno Data Science. And then from there I attended a boot camp, and so I'm here to share with you what I've learned over the past couple of months. Okay, but before we get into machine learning, we're going to talk a little bit about data, because you can't do machine learning without understanding the data. So what generates data? Where is data coming from? So there's so many different places. It's coming from software, it's coming from websites, it's coming from mobile, wearables. These are just a few sources. So everywhere you look, there's data. And where are all these data sets being stored in? They're in databases, both regular SQL and then NoSQL. They're in Excel files, they're in text files, they're on the cloud. We have data everywhere. And how do we access data? We either connect through a database connection, through an API, we download a file, there's web scraping. There's a lot of different ways to access the data. So let's just explore one simple metric, and that metric is how many people registered for this event. So if we look at our event site, we had 12. Okay, that's not too complex. If I tried to access this data to put it into some kind of report, I'd come into some issues because I'd probably have to download the data. I don't think the site has an API or anything. So automating the access to the data would be the only challenge that I could think of. But it gets complex very quickly. So a lot of the complexities that I've experienced as a data analyst is even with just one data source. So we're just talking about one application, is we have missing data, duplicate records, stuff is entered in all kinds of different formats if it's a free text entry. So reporting on all this stuff and creating dashboards becomes very complicated. Also, historical data isn't always there. Most of the time, when you're designing software, unless you're asked to keep a record of something you delete actually deletes, and update actually updates. It doesn't update and store, unless that's in the requirements. Okay, so back to our one simple metric of how many people registered for this event today. So we actually have two data sources. We have the regular event site, and then we also have, Nick has developed an application or a website for us, right? TracyDevs.com. Oh, is it Eventbrite? Okay. So as far as so the last couple of weeks, maybe I've, asked Nick here and there, hey, how many people have signed up? I'm not going to ask you what the process is of how you got an unduplicate account. Because, so for example, on one site, I'm Lourdes Lopez, and on the other site, I'm Lourdes, my full name, and then a different last name. So I'm not sure how you matched people. I'm guessing that was a very manual process. So, okay. So when you're looking at data, you really want to focus on what question you're trying to answer. You're not going to just bring up data and start analyzing all kinds of things for no reason. You have a question in mind. So for us, the question is how many people registered for the event? And different audiences are going to have different questions. And even that same number is going to mean different things to both me and you, me and Nick, as an administrator. So as a presenter, the number of people that registered, to me, what I will use that for is to customize the presentation. Do I have a lot of experts on this topic coming in, or is it a lot of entry level? Those are the kind of things that would be important to me. But that same number to the group administrator is going to mean something different. The group administrator might be looking at what topics are in higher demand. Does the day of the week matter? Is our group growing? Is it shrinking? There's a different meaning that he's going to get from the exact same metric. Then once you have the question, you need to refine the question, because the question of how many people registered for this event, really what I'm asking is how many people are going to attend. And for that, we need to know how many people are going to show up that haven't registered. That we can probably average out over time. And then how many people that registered will not show up. Okay, so can I predict who's going to not show up? If I have 10 members in the group and I know them, it's the regulars, we're going to be able to look at that list and easily tell, because we have background knowledge on who's likely to show up or who's likely to not show up. Now, if it's 100 members, we don't know most of them, and we have several data points, like how many other groups do they attend, how often do they show up to those after RSVPing. Something like that, we can use data analysis techniques and visualization, and this is where the majority of my experience has come from, is summarizing the data, visualizing it, looking for those trends. But what happens if 1,000 members are not going to show up to this event? But if we're talking more about maybe like patient data, where it's 1,000 appointments, or maybe a business and there's 1,000 bookings. So can we predict how many of those appointments are actually going to show up? Is if they don't show up, there's a lot of money involved. So for example, like with patient data, if you line up a doctor and all of the staff and all of the equipment needed to do a procedure and that patient doesn't show up, then that could be potential misuse of resource. Okay, so this is where machine learning comes in. And so my question is, can I predict no-shows using a machine learning algorithm? And for this, I'm going to use Python, which is an open source language. And then the libraries that are going to help me with this are Pandas, Matplotlib, Seaborn, and scikit-learn.
What are Python libraries? Sorry, I don't know.
Oh, that's okay. So Python libraries is a collection of, like, somebody else has already written the code, and then you just bring it in and you get to reuse it. Okay. Oh. Okay. So machine learning, it's an algorithm that, like I said, somebody has already written. And we're going to give it data. And then that algorithm is going to give us back a predictive model. So for example, if we give it patient data, it's going to give us back a model that could predict if a person is going to show up to that appointment. If we give it data regarding like this group, then it can predict if someone will show up. Okay, so how do we get started? The development environment, what you do is you download Anaconda, and this is going to give you a platform with a lot of different machine learning tools, but the one that we're going to use is the Jupyter Notebook.
Is Anaconda free?
Yeah, it's all open source.
It's all right. Got it.
Oh, you know, I'm not 100% sure on Anaconda. I know the Jupyter Notebook is, but I mean, it's free, but I don't know, like.
So what does Anaconda act as? Is it just like a package repository for different machine learning tools?
Yeah.
All right.
So you just install that, and then it just gives you everything you need, all the tools, and yeah.
And you can just enable the ones that you need?
You know, you didn't get an option for that, I don't think. It just downloads everything.
There's one offshoot of that called Miniconda.
What's it called?
Miniconda.
Oh, I haven't heard of that one.
Looks like it's just like a smaller set of installation.
Oh, okay. So you do get an option. Mini or not mini? Okay. And then, so where do I find data? I left out the most important one, which is whatever software you're working on or whatever software is being used at your organization. Obviously, that's the data that you know the most, and that's probably where you're going to have questions in, so that's probably the best place to get started. But if you don't have that, then there's lots of resources that have data sets out there, like Kaggle.com, data.gov. Google has a search where you just type in a topic and it gives you data sets, and then
I don't know if you plan to go over this, but what makes a good data set? Like how, like, I assume you don't want to just throw random data at them, right? Or maybe you do, I don't know.
No, you don't, because you want to have a question in mind of what you're trying to answer. So most likely you're going to have a question on data that you already have access to. But
maybe like how rich should this data be? Like
the more you have, the better.
So multi-tier component levels of the data. Like I'm trying to think of an example.
Well, like when she's looking at how many people are attending,
Yeah.
can she drill down into that data
Yeah.
to find out where they're coming from and how much experience, that kind of stuff?
Yeah, that's what I'm talking about.
Oh, yes. So as far as the features,
Yeah.
it's just going to depend on the question that you're asking.
Right.
So once you start looking at the data, you'll see that there's some features that you can automatically take out. And then there's also like some algorithms that help you determine which. So if we're looking at like a data set with like columns and rows and columns, it'll tell you which columns are most important. So then you can say, give me the top 10 of the most important, and then just look at that. Okay, so the data set that I chose, because I didn't ask for access to the to the Eventbrite or the other source, that I went and I found some appointment no-show
20 records
data
have
set.
been enough for,
Probably not. Like I said, the more data you have, the better. So what I found was this data set for medical records off of Kaggle. And then I don't see anyone following along, so I'll just go ahead and I do have the GitHub. I have the notebook on there in case you want to play around with it later.
and you'll share these slides with us at the end, and I can upload them to the meetup page?
Mhm.
All right, perfect.
I can do that.
If the video fails, I don't know.
Oh. Okay. Okay, so I have a data set. Now what? We're gonna open up Jupyter Notebook. We're gonna load the data in, take a look at it. We're gonna go through it and model it for a machine learning algorithm. So what we're gonna do is, for example, we're gonna change everything to be numerical. So for example, like gender, instead of having one column that says female or male, we're gonna switch it to 2 columns. Gender female, yes, no, or 1, 0, and then male, 1, 0. Then we're gonna run it through the machine learning algorithm and take a look at what comes out and see if we can refine it any further. Okay, so the first libraries that we're gonna use are pandas, matplotlib, and seaborn. That's tiny. Is it? Yeah.
Might be like control plus or something.
Control plus.
Might be.
Oh, yeah. Is that better?
One more time?
One more control plus.
There we go.
Okay. Okay, so this is what the notebook looks like. I've already went ahead and wrote all the code for it, so we're just going to kind of navigate through it. So when you start with the Jupyter notebook, you get these little boxes, these little cells where you can either write code or you can write Markdown to write your notes on it. So all of these ones that don't have code, that's what I've done.
So the ones with code, what's actually happening is that, are those a flow of commands that are going to be executed?
Yeah, I'm going to execute them one by one. Okay.
So if it was Markdown, it just like a comment, or what does Jupyter do?
So that's my Markdown right there.
I know, but the Jupyter notebook was.
No, I have to execute it. So to execute it, you could either hit that button up there, here, run. Oh, you could also execute everything all at once. But yeah, so the way I execute it is just Shift Enter.
Got it.
Okay, so we don't need these. Okay, so the very first thing I'm going to do is import the pandas library. And what that's going to introduce is a data type called a data frame, which is it's basically a table. So you're going to have columns and rows instead of like just an array or all the data types that are.
So it's going to be a matrix?
Yeah,
All right.
yeah. So I'm skipping over the actual syntax of Python. I hope that's okay. Because Python is, if you know any other development language, you're going to catch on to Python very easily. It's not too complicated. Okay, so the next thing I'm going to do is read in the CSV file that has the data in it. You can also, like at this point, this is where you can connect to lots of different data sources, like a database or an API. But the data set that I found was in a CSV. So once the little number comes up on here, you know that it executed without errors. Okay, so I loaded the file and threw the data into this thing called df. And so now that's my data frame object. So let's take a look at the shape. What does it look like? I have 110,000 records and then 14 columns across. Okay. So then these are the data types of the data that's in there. I have a patient ID, appointment ID, and then some characteristics on the patient. And at the very end is the flag of no-show. Okay. Then if you run this command, it shows you the top 10 as a table. So we can take a look at the data.
Put these codes in already yourself.
No, the data that I downloaded came this way. It came nice and clean already.
Is it like a CSV or?
Yeah, it was a CSV. So if I were to open it in Excel, it would look exactly like this.
So is any calculation happened on it right now?
No,
All right.
I'm just looking at it. I'm just like, hey, basically I just opened up my Excel file.
So when you said it's looking at the top 10, it's just the first 10 file of records?
First 10 records. And then by default, it does the top 5. I don't know why I put 10 in there. I think I was just playing around with it.
But the contents in those boxes, those are already there.
They're loaded into by the CSV.
Yes, I loaded that.
She downloaded the file.
Are you referring to the Python lines or are you referring
Yeah,
to the output?
there's like those.
Oh, the code?
Yeah.
Oh, yeah, I wrote that earlier
Okay.
because I didn't want to stand here and write and mess it up. And
It'd be there if you were to open this notebook.
yeah, so if you download it from GitHub, you're going to have all my code already. And then you can play around with it. You can edit it. Okay. So next I could look at statistics on all of the columns, of my 14 columns across. This is a little summary of the data that's in there. So for example, the patient ID, well, it's kind of treating it like a number, but it's not really a number, it's an ID. And
Is it like attempting to average?
yeah, it is. But patient ID, because we're trying to do a predictive model and we're going to use it for a new record, we're going to take out all of the columns that are too unique, because we're trying to identify scenarios, more general scenarios that this patient might fall into.
So I'm noticing that some of these columns have mixed data types. Is that an issue when it comes to this analysis? Like that neighborhood looks like it has string and integer in it.
Which one?
Neighborhood? It looks like it has string values and integer values.
I think they map to the left.
Oh, am I looking at wrong?
Yeah. 'Cause
Yeah.
the number of different neighborhoods is.
Oh, all right.
So I have 81 unique different neighborhoods.
Got it. Yeah, all right.
Yeah. And then there are different data types in the set, like as we saw up here.
But I mean, mixing them for the same column, it's not going to happen, right?
Oh, no, in the same column, no.
All right.
So like each column has just one
Got
data,
it.
one
Yeah,
type.
It didn't look like that at first.
So you could also do the statistics just by type, so that you don't have all these NaNs in there, all the nulls. So these are all of our numerical columns. And like I said, we'll be removing the patient ID and the appointment ID because they're too unique. Okay. So that's what this line of code does right there. So now if we look at our data set again, we no longer have patient ID and appointment ID. So let's keep going. Huh?
So when you did that, it looked like you were reassigning it, like df equals df dot drop.
Yeah, I'm reassigning it to itself.
So drop doesn't alter the table itself initially, right? It gives you a new table with everything except the dropped columns.
That's correct, because I could assign it into like, I could create a different data frame and have 2 copies of it, and I could have the original,
Oh,
and then one with those 2 dropped columns. But
that's useful. So you don't actually ruin your original data. By
oh yeah, no, and So I work a lot with SQL, and I mean, you can't really change the data in the database to do your analysis. You have to do case statements and stuff like that. So this is really nice because you have a copy of it.
It's a lot like slice in JavaScript since you mentioned in JavaScript.
I think there's a parameter called place that can set the true or false to either update or update.
Oh, nice. Okay, so where was I? Okay, so I'm going to create a feature called, and I'm going to call it Day of the Week because I think it'll be more useful to group all this data by day of the week instead of each individual date, especially when a new record coming in is never going to match the date of all the data that's already in there. It's going to have a new date, but it will match a day of the week. So if we scroll across over here, I now have this new column called Day of Week. So then here's just a unique on that one column, just to make sure there wasn't anything weird going on. I noticed that scheduled day has the timestamp on there, and I want to use that to calculate the number of days between the day that they scheduled the appointment versus the actual appointment date. So I'm just going to remove the time out of there and then calculate that field. And then kind of look at it. So here I do notice that I have my minimum value is -6. So that's saying that somebody scheduled their appointment after they attended their appointment. At this point, I don't know how many records have that scenario, so I'm going to take a closer look. Okay, so for that, I'm going to use matplotlib and seaborn, because within this notebook, I could also graph data and then look at it in here.
What was that question?
Uh-huh.
So was the pandas, that's the first one you used, so that looks to be like a data cleanup library? Is that what that
Yeah,
okay.
yeah. And one thing that this does is I also tried to learn R for a while, and what I like about this is you can do joins in here.
Okay.
So you can bring in.
So each one of these libraries is like you're going to go through each one and.
Yeah, they all have their own like unique thing that'll help. So these are the ones for data visualization. And so, okay, so let's take a look at that -6, what's going on there. I'm going to just import those libraries. And then, again, to rerun that, take a look at that date. Okay, so now let's graph it. So we have this huge number of records that that has 0 to 24 days. That's within that range. So our little range of what's in the negative side is so tiny that it's not displaying on there. So I'm just gonna filter for just anything that's under 0 and then take a look at that a little more closely. So here I see that I only have 4 with a -1 and 1 record with a -6. It's not a huge chunk of the data, so I'm going to go ahead and just remove those records from my data set. It's he's asking is because they're invalid. Because most likely a new record coming in isn't going to have a post-dated schedule date. So I'm trying to predict. Yeah, because I'm trying to predict. If we go back to the question, I'm trying to predict who's not going to show up. So if you're backdating the scheduled day, you already showed up.
Could it be a patient scheduling for a future appointment?
That's what all the other records are. So these 6 are those ones where the scheduled
They
date.
came in already, and then they're like, okay, I need to come back in again to do a follow-up.
It did, yeah, yeah.
So, there's some level of assumption when you're like going through data that the data entry has been done properly. So,
Yeah.
it just depends.
And when you're looking at your own data, you're probably going to know those scenarios, and you'll probably understand your data set better. So this one, like I said, I found it online. So and it could have been a calculation error as well, but it's such a small percentage compared to the rest of the data set that I'm just going to go ahead and remove it. Okay. So if we look at the shape again of the data frame, I'm down a few. And then now I'm going to remove the appointment date and the schedule date because new records coming in that I'm going to use to predict are probably not going to match past dates. So I'm getting rid of those.
Could you have used a calculation like people who schedule their appointments 3 months in advance are more likely to make that appointment than people who did it the week before or something? Could you have used a calculation in machine learning?
Yeah, and that's what I'm trying to do. So I calculated how many days are in between the appointment and scheduled date.
Oh, I'm sorry, I missed that.
Oh, it's okay. I did try months, but everyone fell into month 1, so it just made more sense to use days.
So the assumption is like booking date and the actual appointment date, if you have more time, there is a chance of missing. Is that right?
I'm not sure. that's what I'm gonna find out. And like I said, there are. Oh, sorry, go ahead.
I was going to say, are we still looking at just the first 10 records, or are we now moved on to the full data set?
Every time we're always doing the calculations on the full data set, but when I bring it up to show it, I'm only showing the first 10, because or else it's just gonna be like, yeah, we don't want to actually scroll down through. Yeah. Okay, so another thing that I noticed was on age. When I had the statistics up here, I have someone that's -1. And like I said, I don't have a count on that. I don't know how many people are -1. So we're going to take a closer look at that as well. Okay, so here's the statistics again. I also have a max age of 115, which is possible. But -1 probably not possible. Okay. So again, I'm filtering just for those that are under 0 in age. And when I look at it, it's just one record. So I'm going to go ahead and get rid of that one as well. Okay, so at this point I have a few less records, and I didn't plot anything with Seaborn, but I just kind of want to show you the things that can be plotted. It's pretty neat. You could do all kinds of visualizations on the data. So pretty much any way you want to look at it, and the code is very simple. So like this little chunk of code is going to plot these graphs like this.
Maybe this, I guess, next question too. So how many data points would make like these graphs look so cool? Is it, I guess you had 100,000 in yours. I guess that would be kind of somewhere around there. I guess 10 would just be 10 dots on the.
Yeah. And there's so many different varieties. Like there's some. I mean, this could be like a whole meetup on this, right? There's variety in here. There's a lot that you can do if you really want to just look at the data.
In general, is the map hardware like in the basic terms?
Yeah. And then Seaborn is, I believe it's built on top of it. Not 100% sure. All of these libraries are kind of built on top of each other. It might be. Yeah. It's built on Matplotlib. Yeah. So the next thing we want to do is, like I mentioned earlier, with gender, we have, it's not numerical, so we want to switch that into numerical. And we're going to do that. We're going to do that for gender as well as for the appointment day, because remember we calculated that, and so we have like the actual word, like Monday, Tuesday, Wednesday, Thursday. So we're going to calculate that to ones and zeros. And that gets done with one line of code, which is pretty awesome. Especially with someone coming from SQL, to do that in SQL would be just outrageous.
In economics term for dummy variables,
Uh-huh.
it's
Yeah.
where like an enum is separated out into all of its, like you're just expanding all of the possible values as columns,
Yeah.
and then it's a Boolean array.
Yeah. So and now if we look at, if we like scooch over here and we look at, now we have appointment day of week Friday, we have Monday, I mean it's not alphabetical, but now we have ones and zeros. And now this is something that we can plot. The only thing left on here that can't be plotted yet is, well, we still have this neighborhood. But remember we had 80 different unique neighborhoods, so I didn't want to scroll all the way that way. So I kind of put that just separate on the side. Yeah. So now I've done that with neighborhood as well. And like I said, now we have 98 different columns, and like each neighborhood has a 1, 0. Okay, so the only column left to kind of manipulate is the actual no-show column. So it's a yes or no, and I want to convert that to a 1, 0. So that line of code right there maps it over to 1, 0. And
So how does it do that?
dot map.
Oh, and it just changes all the yeses to one.
And you can have more. So yeah. Okay, and then the last thing I'm going to do is move it to the end of the data frame. And at this point, the model is ready to plug it into a machine learning algorithm. But before we do that, I kind of want to go over just a few more slides. Okay, so now we're going to switch to scikit-learn. And the machine learning model that I selected was a supervised learning logistic regression. And that's going to give us numbers between 1 and 0. Okay. Did I lose everyone? You didn't sign up for math. So just like with everything else, you don't have to actually write the code that for the algorithm. It's already created. You just have to, but you do have to understand what it's doing, how it works, and then how to configure the different parameters that you can specify. And then supervised versus unsupervised, the one that I chose is supervised, so that means that we have the answer, right? In our data set, we have that column that says no show, and we have ones and zeros in there. There's other algorithms that do unsupervised where you don't have the answer. And then another term that is a machine learning term is features and targets. Target variable, so the target variable is the answer, the no-show column, and then everything else is a feature. So all of the different characteristics. Okay, so here we go. On the machine learning. This is just importing that library. And okay, so I'm going to take all of the features. So I moved the no-show column all the way to the right-hand side. Everything before it, I'm going to move into X. It's no longer going to be in a data frame. It's going to be in an array. So it looks like that now. So this is what we're going to feed into the machine learning model. And as you can see, these are all numbers, which can be plotted.
Negative 1 is the last column, or
The negative one?
Should either be 1 or 0, 0 for no, no should 1 for.
Oh yeah, so that, I left that one out. That one I'm going to put into y, into a variable that is called y. And so that looks like this now. These are the answers. Then I'm going to split my data set into two. 70% of the data I'm going to use for training, and then I'm going to leave 30% so I can test it. So I'll train it with 70%, and then that 30% is going to see, like, did it predict correctly or not. Okay. So that is importing the library. And then, and that actually, that code right there, split the data set into two. So now I have 77,000 records in one and 33,000 records in the other set. And then for logistic regression, we pass in the X and Y variables from the training set, from that 70%, and then use the test set to predict. So that didn't take very long, like a second. From there, we get a score. So this model is 79%, can predict a no-show with 79% accuracy. So if we were to have a new record, it's going to be 79% accurate as to whether that person is going to show or not show. And then from there, the next step is just to run it through all of the data, and then you can save your model. Okay, so one other thing that I wanted to show was the scikit-learn library and all of the different algorithms that are available. Gosh, there's so many. So the one that I picked was regression, and I picked logistic regression, like I said, but there's other ones. I'm still doing a lot of learning myself on how to use them, what they're best for. You can run your data set through several of them and see which one can predict better. So for example, I also used a decision tree. That one gives me a score of 73. So the logistic regression one is a little more accurate. Okay, so.
how much accuracy do you want to get out of
It depends. I mean, it depends on what you're okay with. You can go back and create new variables or like manipulate the data in a different way. Come up with, maybe do a month. Like you said, instead of calculating how many days between the scheduled and the actual appointment, and look at months instead. You can group age into categories instead of individual age and see if that improves your model. So it just depends on what you're comfortable with saying, okay, this is good. Okay, so we have this new data set now. Can anybody tell me what kind of question you
Going back to the other one. So with that model,
Oh,
if someone's scheduling an appointment like on a Tuesday, then you can say with 70% accuracy if they're going to keep it or not.
Mm-hmm. Yep. And that's why we got rid of like those columns, like the actual date, because a new record isn't going to match a date from your old data set.
I'm new to this.
That's okay.
So
So
my
am I.
obvious question is, where should I start in order to get to this level? Because I could understand the science behind it and what you're trying to accomplish, but the technology itself, I never used Python. In my
So I can kind of tell you how I got started. Like I said, most of my experience is data analysis and visualization. So I end at, let me summarize the data and let me present it, and we can look at the past, right? What's happened, and not really predicting the future. But at my job, my director wanted to do some of these data science techniques, and so he gave me a book. And if you recall my slide with the logistic regression, I mean, it's pretty dry. Like, to just read that and try to comprehend it was very difficult for me. So then from there, I looked at other options, and I found a meetup in Fresno, and I just got really lucky because the presenter there just, has taken a lot of time to go through and explain everything. I've been attending it for about 6 months, maybe, and that's what worked for me so far.
I'm curious. So you had like 110,000 records.
Uh-huh.
So relatively small. Like, what if you had a massive data set? Does it support streaming, or like, how do you deal with really massive data sets that you need to train?
I'm just not there yet.
Oh, yeah.
Yeah.
Well, I mean, that doesn't really work.
With comprehensions like that are really fast in Python.
Well, I'm thinking space complexity is what I'm thinking.
When you start getting into like millions, in fact, even for like a million, it would probably still be pretty quick.
Sure.
But when you start getting into billions, maybe even trillions of data sets, then you have a whole new problem space to solve for. And in that situation, I'm sure that these tools have sufficiently complex like resources, but essentially the problem space almost like isn't the same thing at all once you start getting into such massive numbers.
And I just haven't gotten to those types of examples yet.
Would you be using tools like Apache Spark in that
Yeah,
case
I think so.
help
Yeah.
accommodate the load?
Yes, basically GPUs on Amazon for basically just to train your models and stuff like that is really done.
Yeah, but I was thinking more in terms of like, memory, space complexity with memory.
You'd have to like probably rent a URAC, something like that. So go to Amazon, pay them $300 for the span of X amount of time for Z amount of RAM and GPU. GPU is probably going to be much more important than memory, just because you'll probably streaming.
I think Spark does that. I think
Spark does that?
I think so.
Okay.
Spark is designed to be able to process petabytes of data.
That would make sense, yeah.
And I know that it's used for this kind of stuff.
Yeah.
That's about the scope of my knowledge.
and that'll come down to like data manipulation as well. So if you're able to cut out a certain number of rows, you'll probably want to do that in a cleaning stage, stuff like that.
And you need to use PySpark.
PySpark.
Yeah.
Oh,
it's a
okay.
combination of
Yeah, that does sound familiar.
You need to use and combination of Python, you need to use PySpark. And moreover, before coming to this Excel sheet, the CSV file which we are using as an input. So before that, we have another concept called data engineering.
Yeah.
So there, like a set of developers will be there. So it's Excel sheet is showing very simple, like you have some 100K records, but there is another technology where group of people will work and pull the data from different data sources, legacy sources. That is not here because we are just using the CSV file. The background of them, you need to write a lot of code to generate the Excel CSV file.
Yes, yes.
Yeah, we need to pull out from different legacy systems, and it's a different set of developers will work on that to generate the CSV file. So in this example, like it is a simple one. The example is very simple, but in real time, you need to pull data from legacy systems. Some data might be streaming data, some data will be some other formats, unstructured, structured data. So somebody should get that and generate that CSV file in a meaningful data.
And yeah, exactly. Sometimes that's the hardest part right there. Okay. Okay, so we have an example of another data set here. Can anyone kind of give me a question that can be answered with this data set? Okay. So my point with that is domain knowledge. If you don't know the data that you're working with, it's going to be very difficult to answer any kind of question with it. I mean, you can convert that into numbers and plug it into a machine learning algorithm. Which one? What meaning are you going to get out of it? Okay, and then other Python libraries that can be used for machine learning. There's one that works with text. So for example, if you have a sentence, you go through and you take out the punctuation, and then you go through and you put it into, separate each word out. From there, you take out the words that are like I and A that are, there's a term for it, I forgot the term, that are used often, right? And then from there, you convert that to numbers, and then again, you apply a machine learning algorithm to that. Another example is images. So again, you have an image, and you convert it into, again, numbers. And once you have it as numbers, then you can use the machine learning algorithms.
What's it doing with the image?
This little piece of code right there is just converting it to numbers.
But to do what? Like, what's the algorithm doing?
Oh, there's so many different things you could do with it. So once you have it in numbers, and you can plot it, and you can group images together that are similar. And there's, it's a whole world.
Google has some, like they have their filtering. You can filter on color and filter on different things in their images section. So that must be what they're doing.
Nowadays, you can even, if you have like Google Photos or something like that, you can even type in like cat or dog,
Yeah.
and we'll go and find all of them.
That's cool.
Yeah, they've been making that a lot easier nowadays. A lot. Very scarily easy. I'm not happy with it.
So again, this was just a small first step intro into data science and the Python libraries for machine learning. There's so many problems out there to be solved and so many questions to be answered with data. And then again, my recommendations is if you're new to it, then spend some time on the terminology, because I know when I was learning it, a lot of the phrases I had never heard before, like unsupervised versus supervised learning, or features and target variable, stuff like that. And if you're in the Merced area, I'm gonna try to start a developer meetup out there. So if you're interested, I don't know if where most people are coming from.
I actually used to live in Merced.
Oh, okay.
Until like just this January, I moved back to Modesto.
Oh, okay. So this would have benefited you.
So this meetup group is in Fresno, the one you're talking about?
Oh yeah, because I live in Merced, right? So it's either I drive to Fresno or the Bay Area, just kind of, I guess, further, or out here to the Modesto one is the one that I started going to recently, just last week. It's the same distance for me. There aren't really that many meetups in Merced, so maybe I can get one going. If anyone's interested in speaking there, that would be helpful. And then again, back to our original metric of how many people actually attended. If you signed up as you walked in the beginning, when we first started, we now have 3 different data sets of where all of our data is stored for one simple metric. And so thank you for coming.